Good morning. We're back. Oh my goodness. Good morning, Oblivious. How are you doing? Good morning. Let's see. This goes here. That goes there. Got that set up. We need to pin a message. Let's see. Good morning. We are playing catch up today, trying to see if we can do two puzzles in one stream. Should be a good time. If you are new here, try commands for more context. Let's pin that message. Okay. I'm going to start making coffee this morning because I woke up a little late and I didn't have a chance to pull a shot of espresso before I came downstairs. That's what we're going to do first. Oh goodness. First things first. The goal is to always keep the goal the goal. Let's see. Okay, I'm gonna go set up the coffee camera real quick. Alright, to the coffee station. To the coffee station.
Here we go. Coffee first. Coffee first today. We gotta do two problems in one day. I don't know if it's gonna happen, but we're gonna try. We're going to give it our best shot. Hold on, let me do this first. Let's see, we're day, what are we, day 19? Day 19. Let's go. Colombia, John Diaz, Pink Bourbon. That's quite a name. That is a mouthful. We're supposed to taste lime, cacao, milk chocolate, and round. Better taste like coffee is all I gotta say. Better taste like coffee. Whew. I need more outlets. Smells good. Good morning, lads. How are you? I hope your day is getting started well. Mine is. Making some coffee. We're going to try to solve 2 Advent of Code puzzles. I was going to try to stream last night, but I forgot the Los Angeles Rams. They're kind of my favorite American football team. They were playing Thursday night football last night, so I ended up not streaming. So I'm officially a day behind. But I think we'll be able to solve it today, and then hopefully we'll make some good progress on day 10. We have to do day 9 part 2 and day 10 part 1. Whew. I'm good, bro. Thanks. How about you? Yeah, I'm great, man. Like, I'm healthy. My wife's healthy. My kids are healthy. Like, it's the rest is all icing on the cake, you know. If you have your health, you're a wealthy man, you know. If you have your health and the health of your loved ones, there's not much else life can throw at you to fuck you up. Pretty much everything else you can kind of sort of fix, you know, to some extent. And that can change, you know, in an instant. So you just got to kind of always be grateful and super thankful and appreciative for that fact, you know. Ba 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 ba. Well, what should we opine about while we wait for this coffee to brew? Should we opine about the impending doom of our obsolescence by AI? Is that what folks are talking around the water cooler now about at the office? Or should we talk about, what else should we talk about? Should we talk about why TypeScript's a better language than Python? Or should we just sit quietly and enjoy the ambiance? My family's coming into town today. That's fun. Holidays, you know. This is my last day of work too before the holidays. What about you guys? Anybody else taking time off? We sit and wait. Oh. If you're new here and I haven't showed you this before, this is, we're doing an advent calendar, but it's coffee. And this is the package that the advent calendar came in, which is first things first, like how cool is that artwork, right? And then second, if you're interested in coffee, this is a pretty cool coffee brand. It's called Onyx Coffee Labs. I'm not sponsored by them. They're based in Northwest Arkansas here in the United States. But if you're into coffee, you should check them out. So just shout out to them. Again, no sponsorship. They're just a brand I fuck with. So I figure I share them with you guys too, especially if you like coffee. Crap, I forgot my watch upstairs. Smells good. Hey, good morning, Cyberlinka. How are you? Wholesome snack moment, basically. Yeah. Basically, we're starting with coffee this morning because I woke up a little late and I didn't have a chance to get espresso before I came downstairs. So we're gonna get coffee and then we're just gonna dive headlong into trying to solve two problems today, and we'll see. We're part of the way there on one already, so it's not really two full problems. It's more like maybe like 1.5 or 1.25. So we'll see. We'll see how it goes. This will be, if I finish day 9 part 2 on a percentage basis, this will be the furthest I've ever gotten in Advent of Code. So it'll be a new PR for me. So I really want to finish that day. If I don't finish any of the others, that's fine. But I really want to finish day 9. That'd be a PR. That's kind of my goal every year. It's just like in 24 days, can I get further than I got the year previous? That's sort of my goal usually every year. All right, here we go. It is time. To the office. No, chat, in here. In here. Come on. You guys don't listen no good.
There we go. Now we're all together. Okay. Okay. Oh, hold on. Let's go. All right. Solving part 2, day numero 9. Okay. Let's see where we left off. So where we left off was we were max row, max column. I don't know if I need those anymore. I don't think I do. So what we're trying to do right now, if I recall, is we basically just need to filter out rectangles. Yeah, we need to filter out rectangles that aren't in our polygon, and the way we're doing that is we're going to use the center point, and we're going to check if the center point is inside the polygon, which is what we're implementing right now, and then we're also going to check to see if the edge of the polygon intersects with a edge of our rectangle is basically what we're going to do. So the point we're checking, we're using, I don't even know there's a name for it, but I'm not sure what it is. But what we're doing to check the point is we're basically just doing this, where we're saying, okay, does center intersect? That's the wrong color. Does center intersect with the polygon's edges? And if it does, we're basically keeping track of like how many times we enter and leave the polygon, essentially, is what we're doing. So we're basically doing some like line math, some y equals mx plus b math to figure it out. Let's see. I'm gonna do red. No, pink. That's kind of like a pinkish red. Yeah, so we're basically doing this. So first thing we do is why is that not changing the color of my... Oh, I have to change the stroke color. I see. God, I've been using Excalidraw for so long and still I don't know stuff about it. Let's see what we're gonna do here. And then we're basically gonna ask the question. We're gonna ask the question here, right? Are we inside? And do we intersect, right? So we start outside, we intersect, we're inside, we intersect again, we're outside. This was in a problem last year. I can't remember what the problem was last year. Don't think it was exactly like this. I think last year it was a little bit more like you're traversing the grid and you're counting how many times you cross over a column that's listed or something like that. There's a term for this. I don't know what the term is. Okay, and then for the vertice or for the intersections, we are going to basically check, does this polygon edge, does this edge run into the rectangle, right? So the way we'll do that is if we have a edge that's formed by two lines, right? So this would be our edge. Then what we'll do is we'll basically say, does this rectangle edge, does it intersect there? That's basically what we're gonna do. We're part of the way there on the first check. So we've got our min max. Okay. Now we're looping over and we're figuring out the edges. This is where we're doing our line math. And then if center is inside, we continue. And this is where we need to do our intersection check. Although this is saying I don't need a... Do I not need a... Oh yeah, I guess I don't. So the thing that was confusing to me yesterday was the fact that, well, the thing that was confusing to me yesterday that I didn't know about our input is that our input is actually sorted properly. So you can see these vertices or these points, they all lead off each other, right? See how they all share the next one always shares a value from the previous, which means this is literally drawing that polygon, which I didn't realize was the case. Which is why looping like this works. Okay, so we need to do this. That's our line math. Looks good. Okay, now we gotta do the intersect then. So let's come down here. And let's say, okay, if center is inside, we continue. Now we need to check the intersect. So we're gonna have a similar loop. Which this actually, I don't know about you guys, but this seems kind of not intuitive, doing a loop like this. So I think what I'm gonna do is, I think I'm gonna do some modulo math to sort this better. So what we want to do is, basically what we want to do is we want to check edges moving from first to second, right? And on, which basically means we want to go like this: 0. Yep, 0 goes to 1, 1 goes to 2. Exactly, we want this right there. Also, let me silence Copilot so he doesn't help me too much. Which means we can use some modulo to basically say, instead of doing this, which looks funky, we can actually do this, where we actually wrap around the end of the array. So we can say number of position, or no, sorry, not number of positions, I plus 1 mod number of positions. So I'm going to say edge index equals this. Now, the reason this works is because when I is 0, or when I is in -1, meaning we're at the end, the next time we run this, we can do, this will essentially make j 0. J will become 0, which will allow us to do this right here. And that's how it connects. That's like drawing your complete shape. Which means down here we can do the same thing, which is way more intuitive, I think. The modulo math is not intuitive, but the loop looks more intuitive. Should probably have a helper function that's like get all edges and then like iterate over the edges. And this is no longer, this is going to be is rectangle intersected or something like that. Yeah, we're gonna do is intersected by edge, and we'll just start that as false. So assume we're not intersected, right? Wagner, thanks for subbing, man. Also, why didn't that play an alert? I didn't hear an alert. That was weird. Try playing that again. Crap. Hold on, I gotta figure out how to say your name. You're Serbian, so I know I can use Google Translate for this. Good morning, man. I'm just gonna figure out how to properly address you. What's that?
Krupaniec.
Krupaniec. Or do you want me to call you AJ? No, that wasn't you. Sorry. How do you say this in English? Because if I try to do it with an accent, I'm gonna sound dumb.
Krupanjak.
Krupanjak? Is that okay? I guess I should probably try the Serbian. You can just call me Crew. Okay, I'll call you Crew. I'm sorry, man. I do want to be able to pronounce people's names correctly, though. I hate that I'm terrible at it. There we go. I don't know why I didn't hear that sound earlier. Well, good morning, Crew. I hope you're doing well. We're trying to find out if a rectangle intersects with a polygon. That's what we're trying to do. Let's see. So there's two cases we need to check for. We need to check for edges that are vertical, right? And then we need to check for edges that are horizontal. And how do we know if something's vertical? Well, we know if something's vertical if they have the same column, right? They just differ by row, and they just have the same column, then we know that we're looking at an up-down thing, right? So if we do edge start dot column equals edge end dot column, then we know we're vertical. And then we know we're horizontal. If that's not true, then we know we're horizontal, basically. So here, we're horizontal. Horizontal edge. And here we know we're dealing with a vertical edge. Right? Which means now, if we're on a vertical edge, we want to see if, because basically we have 3 points, right? We have start edge, we have end edge, and then we have the center. And so if we go back to our drawing, if we're checking for intersection, actually it's not center, is it? It's the edge of the rectangle. Right? Do I have, yeah, I don't have the edges of the rectangle. I have the rectangle bounds. I have the rectangle bounds. Man, chat's super quiet this morning. We're having ourselves like a nice, quiet, stream. Okay, so I think we can just use the bounds of our rectangle. So if we have a vertical edge, if I guess if edge start dot row, right? Because now what we're doing is we're basically seeing if the rectangle's edge, or the top edge of the rectangle, if that lies between these 2 points, is what we're doing. I'm setting myself Debian on work laptop right now. I lost my patience with Windows for work. Nice, dude. Your work lets you do that? You can just wipe your Windows installation? I don't think my work would let me do that. Okay, so this would be... I actually think this isn't what we want. Actually, what we want is we want to check to see if rec what do we want to do here? We're basically checking if edges sit within one another. So when we do a vertical check, I guess we basically need to see if the min column is greater than the min, or if the current, the edge start dot column is greater than rec min column. Why did that cast that? And if edge start column is greater than rec max column. Oh, because those are floats. That's why I'm an idiot. We don't need these to be floats though, so we can just let's just. Well, that's a lot of parentheses. That's beginning to look a little bit like Lisp. Yeah, so we can cast those. Then we go down here and check. So we're basically saying, okay, is my edge start? Dominic, thanks for subbing, man. Reza, thanks for subbing. Appreciate it. Dog Yuhan? Dohuhan? Thanks for subbing, man. Appreciate you guys. Super, super kind. Okay, so now we basically know that our edge. So if this is our column, yeah, we basically know now that the start of our edge is somewhere in our rectangle's edge. Yeah, so now what we need to do is, I'm going to copy this real quick. So basically now what we know is we know that we have something like this, where the start of this edge is somewhere between the min and max sorry. This the columns and rows are fucking me up. We're checking to see if this has the same column. We know we have a vertical edge. So then we check to see if that edge, that column, right, the column that this edge lives on, is between this bound and this bound, right? That's basically what we're checking to see. Now we need to check to see if there's actually an overlap. So we actually need to look at the rows to see if the row, I guess the min or the max bound of the row sits within the row of this edge, right? So there needs to be some overlap between, there basically needs to be some overlap between this and this. And if there's no overlap here, then we know we don't actually have a true intersection, right? If it was down here, then we have this edge and we have this edge. So there's no overlap. But if we are slid up and those two things overlapped, so it's almost like looking at a range. So if this was, we actually did this earlier in Advent of Code. So if you said this was, let's say this is 0, right? And let's say up here is 2, and let's say this is 1, and then you have 3 and 4 and yada 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 up the chain. We're basically saying, does this range of numbers overlap with this range of numbers? Is what we're doing, right? And if those two ranges overlap, well, we know that we have a true intersection at this point. So this is where we need to calculate. We have to calculate some min and max values for I'm always afraid I'm going to spill my coffee all over my desk. So we need to get edge, min, row. And then we need edge, max, row. And that's where we're going to do something like cast to an int, use math.min, and then we're going to pass in edge start row. This has got to be the hardest day. I hope to God there's not something harder on day 10. And then we'll do the same thing here. Only this is max. And this is max. Okay, great. So we got the edge min, the edge max. And then, because we don't really know, we have to do that because we don't really know if the vertices, which row, we don't really know just based on order which vertice actually has the min and max. And then we need to find the overlap, right? We need to see if there's an overlap. So the way we can do that is we can say, okay, the overlap is going to start wherever there is a math.min between, so we want the minimum of the edges bottom. We basically want the edges, whatever's lowest, the edges bottom, or I guess the edges top, since our coordinate system is flipped, the edges top, or the rectangles top. So this would be edge min row, right? Edge min row. And then this would be, which that's an unnecessary cast. And this would be the rectangles min row. Yeah. Like that. And then the overlap end is the same idea. Only now we're doing the maximums. So this would be edge max row, and this would be, this is again an unnecessary cast. And this would be float 64. What are you angry about? Oh, they're angry because this is the same name. Right, and so we're basically finding the min, or we're finding the top, finding the bottom, and then we're basically gonna say if there's any, if the start, I don't know if I did that right. Yeah, so this would be our, this is our overlap end, and this would be our overlap this would be our overlap start, and this would be our overlap end. So if overlap start is greater than the end, we have an intersection. Oh no, sorry, I'm looking at the wrong direction. We're not looking at, no, we're looking at rows. Yeah, so this is overlap end, and this is overlap start. So so in this case, end is yeah, I can't. Good morning, Wilo Gamer Pro. How are you, man? We're still fighting for our life in this Polygon problem thing that we have going on. So let's see, we want to compare the minimums, and when we compare the minimums, we want to get the, oh, that's where I fucked up. We want to get the max of the minimums, and we want to get the mins of the maximums. And if overlap start then is greater than overlap end, then this is where we can say, oh, yep, we have an intersection. So is intersected by edge gets set to true, and we break. So, which means if we go back and we look at this drawing, so we'd look at, this is minimum, and this is minimum, and so we're going to get the max of those two values, which would be this guy. That's our overlap start. And then we're going to get the maximum or the minimum of the maximums. So that is where we'd say, okay, well, this is we want them. What did I say? This is where it would be super helpful. I should have just took the time to figure out how to print all of this very early on, because being able to visualize this would be so much easier. So we want the minimums of the maxes. And we want the maxes of the minimums. So we want this guy is going to be our overlap. Is that going to work? Because I feel like in this case, hold on, I gotta be able to look at my code next to the drawing here to make sense of this. So we get the edge min, And then our overlap is going to be the max of the minimum row and the rec min row. Yeah, I don't know. That definitely is going to detect some edges, but I don't know if that's going to detect this particular case. It would definitely detect this particular case. What about this one, though? Yeah, I think that's correct, though. I don't know. We gotta try something. Okay, so now let's go on to the vertical or the horizontal. So if we're on a horizontal, we basically need to do all the same thing, but we are just looking at the opposite, right? So we're doing all the same checks, but instead of looking at columns, we're now looking at rows. So the first check is going to be if edge row is greater than rec min row, and this is going to be edge start dot row is greater than rex max dot or rex max row, and then now when we get the overlap, we're not going to use rows, we're going to do edge min column, edge max column, like this. And we want to say instead of edge min or rec min row, we do rec min column. And rec max column. And these are also going to be column. So we're just flipping the logic of our check based on whether the edge of the polygon we're looking at is horizontal or it's vertical. Something about the overlap doesn't seem correct though. Kind of wonder, do these need to be flipped? I need to, what this is telling me is after I get done doing this, I need to go do some game development because this seems very much like something you would learn when building games. Okay. And then the last thing we need to do is we need to say, when we exit this loop, we basically need to check is intersected by edge, right? So if is intersected by edge, whoops, we're not writing JavaScript, Steven. If is intersected by edge, then we just continue. Otherwise, we take this area. So this right here is our edge intersect detection. And then this up here is our, is center of rec inside polygon. And this is our is poly, or has polygon edge intersected with rec. That's what we're asking there. Siyabunga? I think is how you say your name. Thank you very much for subbing. Appreciate you. Very kind. Alright, let's give this a run. I'll be happy if this just, as long as it doesn't run forever, I'll be happy. Let's see, integer divided by 0. Well, that's not good. What line is that on? I mean, it didn't run forever, so it's not an infinite loop, so I feel like that's a win, even though I crashed the program. $103. 103. Vertical distance completed. Vertical edge distance. Vertical edge distance is edge row minus edge start dot row. So what's wrong? Okay? We're getting that. This is our equation for the point check, where we're basically checking how many times we cross over an edge as we move right from the center. That's basically all we're doing. We're basically saying, hey, if I'm moving right from the center, how many times do I cross over? And we're doing math. We're doing a little bit of math to just use a line calculation to figure out where we are as we're moving right from the center. And it appears my calculation is not correct. So we get the edge horizontal distance. Good morning, Rampla. How are you doing? Okay, I'm gonna. This was from yesterday, so. Let's see. What am I doing here? So we're doing the same loop that we're doing down below. We're just looping over all the positions, building our edges. And the first question we're trying to ask if the edge covers the center row. I'm not sure why though I did this. So I'm basically saying if center row is less than the edges start, if that is fall, I don't think this is right. Why? Yeah, did I type this? I must have typed this. I must have typed that at some point. I don't think. I think that's answering the question of that variable, but I don't know why I did the not equals thing. Yeah. This is one of those moments where like you're looking at your former self and you're like, what are you doing? I think the real question I'd like to answer is not it. Okay, this is what I really want to know. I really want to know, is center vertically between the edge? That's really what I want to know, right? This is where I just kind of lag out and stare at the screen. And I think the way we do that is we say is center vertically. I can't believe we have to try to do 2 of these in one day. This is going to be a reach. So we do this and something else. So we say edge start dot row is greater than center dot row. And then we check to see if edge start dot, or I guess we can do the other way. Then we check to see if center dot row is less than center dot row is greater than edge start row. So that means the center is above the center. So the edge start row's here. We want to make sure the center is below it. And because our coordinates start top left, okay. Then center row is less than edge in dot row. Yeah, that's what we want to do. That means we're vertically between there. Oh, also this actually can be, because it's okay if they touch. So it's actually that. Okay, then we're calculating the... Then the next question we're trying to answer is the edge to the right of center? Or put another way, we could say is center horizontally to the left, like that. So if the edge is here or here, where, you know, let's say we're here, is the center over here? Or I guess that looks for, it's my left, your guys is right, but you see what I mean? There's something about my math that's not wrong. So the first thing I do is I get the total horizontal distance. So I get the edge's total distance, vertical distance. I think I might need to slap a math.absolute on this because we don't actually know. These could be negatives. Math.absolute. And then these have to get casted to floats. Edge in dot row. Right? Yeah. And we'll do the same thing here. I don't know where 0 is coming from, though. That's kind of throwing me off. Somehow we're ending up with a divide by 0. edge start column, edge start, edge in. Yep. That looks good. Then we want to get the offset, so we basically want to see how far if we're starting here, where's the row? Oh, goodness gracious. I'm surprised with how quiet chat is. This is the quietest chat has been in probably, I don't know, forever. I think we do need to do. Okay. Let's see. We're still getting a divide by 0 error. So why are we getting that? So it's on, what was the line? 99 now? 98. So we're still getting a divide by 0. Why are we getting a divide by 0? We're taking the row, the center dot row minus the edge start dot row. So this is calculating our offset. And then we're getting the vertical distance. So the vertical distance is what's 0. But why is the vertical distance 0? The start row and the edge in row. These should be different. These should be different. Why wouldn't they be different? Let's do this. This is edge. This is actually, so this is the vertical distance, but another way to say it is it's the total height of the edge. This is the edge total width. And then I don't know what I've done wrong. I feel like this should work. I don't know why you'd end up with a calculated distance or with a total height of 0. Should I even be using the total height there? Or should I be using the width? I think I flipped these. Oh, that's still dividing by 0. Okay, I know, okay, let me just reset here. So I know what I want to do is I want to calculate the delta here. Let's see, let's simplify this. I don't need to cast this to a float, I just need to cast the final result to a float. I need to do both of them. Just adding noise. Then, once we have the total height and the total width, we're going to calculate how far along one of those dimensions the center is by the same ratio. Is what we're going to do. We'll do we're basically doing slope math. That's what we're doing. Is it really already 5:40? God damn it, we still got to start part 10. I should have done this last night. Yeah, we want center percentage of edge height or width. And how do we calculate that? Well, we need to end up with an integer, so we'll have to start by casting that. And then we basically need to say, okay, great, we have the, I swear I'm going to knock over my coffee in the middle of the stream. And it's going to be so bad. So we need to do, let's see. I want to cast these to an int now. Yeah, I guess I do want to cast them to an int. Do float 64. Divided by float 64. And what do those floats need to be? Those floats need to be center dot row minus edge start dot row. And then we're going to divide that by the total height of the edge. Edge total height. Yeah, and then that's going to allow us to calculate this is essentially going to be the edge x at center y. This is the slope math we're doing. This is basically us trying to say if I'm walking on the line that the center's at, right? Does that line hit the current edge that we're looking at? Like, do those things basically cross? Ahmed, thanks for subbing, man. I appreciate you. In which case, that's where we'll say, give me the edge start dot column, and let me add to that the center percentage of edge height, and let me multiply that by the edge's total width. And we'll say, okay, great is it to the left, that means is center dot row less than edge. It's basically the same math. The only thing I did different was I casted it to floats. Index out of range. So now we have a new error. Morning, Ryan. Good to see you, man. How's Lisp treating you these days? Let's see, we got 50, but wanted 24. All right, so what have we done wrong here? We've done something wrong. So it is vertically between the edge. Is... Oh. The row doesn't have to be less than. It can be equal to it. They can touch. We still got 50. Gosh dang it, man. What have I screwed up? So it should be 24 and it's not 50. Hello, Demoger? Hello, how are you doing? Good to see you. Hope you're doing well. Somehow I've screwed up. Edge total width, edge total height. Finally, to tie together all the various atomic functions into one Lisp program that completely automates the fetching of web-based data and generation of floor plans. That sounds like a product, man. That sounds like a product you can sell. That's what it sounds like. Well, getting the rectangle's bounds are correct. This is where like I'm not really sure how to debug it, you know? Which kind of sucks. It kind of sucks. I'm getting paid to develop the software. It is the IP of the employer. Oh yeah, that's true. Totally fair. But I mean, it sounds like that's a product that someone can make a business out of it, doesn't it? Good morning, Danny. How you doing, sir? We're trying to figure out how I screwed up this Polygon detection thing I got going on. I honestly don't know. Nor do I know where to start debugging it. So I'm just gonna step through it and just see if any of it doesn't make sense to me. So we're creating pairs of all the positions in our polygon. Then we are calculating the width and the height. Oh, we should probably... Mutt, thanks for subscribing. We should probably do these first. And then we should probably use these to calculate this. So we should do rec max column minus rec min column. Do rec min row minus. I'm not sure this is our problem. Min max minus rec min row like this. Who's unhappy? Oh, you're unhappy. You're unhappy. Yeah, we should do that. Was that our problem? But it can't be our problem because that was working for part. Yeah, that's not our problem. There's probably a little bit more guarantee there. Danny, have you tried a Marchi? I recently saw it on YouTube and I'm a bit curious. Oh, I'm very curious. I watched DHH's video where he demos it. Every time he releases one of those videos, I watch it. And some of the people in my Discord have been sending pictures of their Marchi setup, and it definitely has me intrigued 100%. I just haven't. Basically, what I've told chat is that I will make a switch to Linux as a daily driver when I get my next laptop. That's essentially my commitment. And I haven't bought a new laptop in a while, so. But whenever I do, I think that's what I'm going to install on it, is a Marchi. It looks sick, man. Some of the people's screenshots on Twitter and stuff, it looks awesome. Looks really, really cool. Do that. Let's see, is this math right? So let me restate this another way. So we are gonna do. We basically want to check to see if the edges start.row is less than or equal to the center's row. But that's not enough. We need to know about the other side of the situation. So we need to say, is centers.row less than or equal to the edges end.row. Yeah. Oh. Is that an issue? Nope. There's some logical fallacy in here somewhere. What it is, though, I don't know because it all looks right to me. I'm calculating the total height. I'm calculating the total width. Let's see. Width is based on columns. Height is based on rows, which is correct. Then we calculate the center that the edge has traveled along the height, which is going to be center.row minus edge start.row divided by the edge's total height. And then we calculate where the edge's x is at this given row, right? So this actually, let's actually call this, let's call this edge column at center row. So we'll say edge column at center row, like this. Which is times the total width. That gives us basically the ratio. Or this gives us basically the ratio, and then this gives us the actual value along that line. Which looks right. July, thanks for subscribing. I appreciate it. Ryan, it definitely could be a product I'll be tying into Outlook's web API in the next couple weeks, hopefully to automatically generate a floor plan on customer request. Woo! You're just taking automation to a whole new level, dude. I love it. I love it. Huh. So is it something in my edge detection maybe? Let's see. We know we do if start column is if edge start column equals edge in column, then we know we're on a vertical edge, right? And then we say if edge start column is greater than the minimum column and less than the maximum column, then we do edge min row, which is going to be edge start dot row, edge in dot row. And then we do the max of that. Then we check the overlap, which is good. We take the minimums, so we get the max of the mins, and we get the mins of the max. Oh, wait. This should be max row. What about down here? Did I make that same mistake? Nope, I have this right thing there. Swap Indie? Hello, Swap Indie. How are you? You son of a bitch. So there was a mistake there, but it's not causing the issue. I mean, I've been a design process and manufacturing engineer for the last 8 years, so why not add software to that and never have to draw another day in my life. That sounds wonderful. Yeah, that's right up your alley, dude. Danny, did I miss the coffee time? We started with coffee time, but we might have another coffee time because right now I'm kind of stuck. I think I've implemented what should work and it's not working. And my input's so freaking large that I'm not really sure. I'm almost to the end of this coffee, actually. I have like, how can I show this to you without pouring it out? See, it's almost gone. So I guess we're due for new coffee time. Swap Indie. I'm a little late to this programming session. What is this code about? Since I see O Vin3. Yeah, you do see that. You do that. Good eyes, man. Good eyes. Let's see. So we're doing admin of code day 9 part 2. Yeah, day 9 part 2. So basically we're doing the opposite of collision detection. So we're basically trying to see if, given a particular rectangle, if that rectangle is purely contained within the bounds of a polygon, right? So we're given we're given a bunch of vertices of a polygon, and we have to check to see if our rectangle bounds fit within it. So we're trying to detect if the center of our polygon is in, or the center of our rectangle is in the polygon, and then we're trying to detect if that is the case, if any of the edges of the polygon intersect with our rectangle. That's basically the problem that we're trying to solve at the moment. See you, Ryan. Thanks for stopping in, man. Have a good day at work. Keep kicking ass and taking names. Keep automating the world. Dude sounds like dude's got a big raise coming his way, I think. If not, doing something wrong. Doing something wrong. Bah. One quick question you head out. Why don't you use matrices? For what I'm doing right now? I don't know. I have no idea what I'm doing. I'm basically just trying to use my limited knowledge to solve this the best I can. So if there's a smarter way to do it, maybe after I solve it, I can get you guys to tell me what the smarter way to do it is. Okay, sounds interesting. Got a new follower. I'm about pathfinding, and this might be interesting for later projects. Best of luck, mate. Thanks, man. Appreciate it. Yeah, AOC is really fun. It's basically like holiday code challenges. You get like one a day. This year it was just 12 days. In the past, it's been one a day for 24 days. So I just split it up into parts. So I do one part on day 1 and then the second part on day 2, and so I make the full 12 days span all 24 days. Joe does AI. What we're building? We're not building anything. We're trying. Well, I guess we're building an algorithm to detect if a rectangle is completely within a polygon, which definitely seems like a solved problem. But here we are. Here we sit. This looks right, man. Let's go check the tests and make sure the tests are correct. So we are calling solve part 2. And things are running to completion, which is good. It means we haven't created like a nasty infinite loop or anything. Let's see, Ryan. Yeah, generate a matrix for the containing polygon and the checked polygon. Then check all the points in the checked polygon are in the container. Yeah, so that could work on that could work on this guy, right? It could work on the example, but it won't work on the input because our input is 99,000. So you're talking about if your algorithm is O(n) squared at the very least of what you're describing, right? You're O(n) squared at the very least, which means you're in like the billions of iterations. So you'll be running for hours, maybe days even, before you actually get an answer. Color, thanks for subscribing. Angelo, thanks for subscribing. Appreciate you guys. That was my original idea for solving this until I saw the input size, and then it was like, nope, that's not going to work. So you have to do you basically have to do math with the vertices that you're given and the rectangle bounds to make it work. I'm not, yeah, me neither. I mean, yeah, I'm with you there, Ryan. I'm not used to dealing with data sets that large either. It's just which I get. That's kind of AOC does that. Like they will do this to you where they'll give you a problem, and the brute force approach works on the example input, and then when you try to run it on the actual input, it doesn't work because it takes too long because the time complexity is too great. And you're like, you sons of bitches. Just let me brute force it, okay? That's how I would prefer to solve everything. Okay, I don't know, I don't see anything in here that stands out to me as being wrong. I guess what I'm gonna do is I'm gonna check the area here, and I'm basically gonna say if A doesn't equal 50, I don't care about you for the purposes of what we're doing. And I'm going to just see why this is not being detected. So in our example here, this one right here is the one that should be getting caught. So if we're looking at our problem, 50, let's see, is 50 center in the grid? I think it's in the grid. So let's print format dot println center is inside, and let's also println is edge intersected. I think the center's in, but the edge should be the edge intersection should have detected this. Okay, so we got true and false. So we did detect the centers in. I think this should have been, I think the second one should have been true. So if we look at our example, let's see, center would be here. Right? Let me see. Let's print that. Format.println center. And this is a hard one. Let's see, EcoPaint. Are you not only checking for the outer edges of the polygon when there could be inner edges of the polygon, like in a U shape that the rec is intersecting? Well, I should be accounting for that. I should be accounting for that with my center check, because I'm basically doing this where I don't know the term for it. We did it last year in Advent of Code, but I'm basically using a line. So I'm basically saying if the center is here, right, I basically draw a line out from the center and I say, how many times does that intersect? And every time I intersect, I say, so I assume we're outside to begin with. And then if we intersect, now I'm inside. If I cross again, then I go outside. Or at least that's what I think that's what I think I've done. Obviously, my math could be wrong. I'm basically just calculating an intersection point along a line. So I guess so the current, what was the center? The center was 6, 3. So going back to my thing here, we have 0, 1, 2, 3, and this is 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 5, 6. So is that in? That's the question. So that's 0, 1, 2, 3, 4, 5, 6. Yeah, that's in, because it's along the edge, so it's in. But we should be detecting edge intersection. Right? I don't know. Should we? Or is that a case I didn't cover? So let's say we're here. This is basically the situation we have. We have something like this. Yeah, this should be detecting intersection here. We should be detecting an intersection there. So this would be a horizontal edge. This would be a horizontal edge. So why aren't we detecting it? Oh. It's as simple as this. End, start. I think it's as simple as that. No. No. It's not as simple as that. It should be that, though. It should be overlap end is greater than overlap start. Oh, and we have it up here, too. This should be overlap end is greater than overlap start. You mother... Oh, hold on. Let me remove this. Dude, I'm kind of close to crashing out. It's on stream. Oh, that worked. That worked, see? Only our... Let's fucking go. Yes. Okay, so that's where I screwed up. So back down here, just to explain what I screwed up. So basically, I was trying to check. I'm basically checking if two ranges overlap. So if I have a scale, and I have at two edges like this, I basically want to see if they're overlapping, right? And so the only way I know for sure if they're overlap is if the overlap actually has an end that's in front of the start, right? If the overlap doesn't have that characteristic, well then there's not a true overlap. Fuck, that's annoying. That's my fault. Okay, so we need to remove all those print statements that we put there. I was getting ready to start cussing at my computer for sure. It was about ready to turn into an R-rated stream. You son of a... Okay, I think I got all the formats out of there. Okay, let's try this again. Good morning, honey. Tisk. Kinnison, thanks for subscribing. Let's see, Swap Indie. What I do for... Oh, good morning, Stefan. Good to see you, man. Thanks for being a member, as always, dude. Appreciate you. Good to see you again. All right, hold on. Swap Indie. What did you say? What I do for legal pathfinding is reading vertices instead of center mass. The taking body of the unit, defining its nodes. After that, just run calculations for each wall node in the room. Sorry if you did that, and I mentioned it again, but I haven't seen the whole code. But yeah, walls would be 2D vectors that are just going to be checked with the body nodes. They intersect anywhere. Yeah, now I see you doing good. Yeah, I'm trying, man. This is not Swap Indie. This is not my. This is definitely not my specialty for sure. Okay, let's see if it actually works on the input though. So let's get whatever it found as the answer. I still have a print statement in there. Dude, if this works, this is very much the hardest problem I think I've ever solved for Advent of Code. See, that should be good. That should be good. Those are all fine. So why are we still getting prints? Did I just not update? Did I just not write it out? Yeah, I didn't write it out. Okay. So we got 50, but wanted 24. This just worked a second ago, did it not? What did I just do? Was I... Oh, the print... I think the print statements screwed me up, didn't they? So it's still not working. God damn it. It's still not working. It's just there was too many print statements for me to see that it wasn't working anymore. That's why. Fucking hell. I don't know, guys. We're really falling off pace. If I can get past this. me see. Let's just rename this stuff a little bit. Let's do current. Let's do next index. Just kind of step through this one at a time and see if there's anything that stands out as being wrong. So let's do current position. Let's do next position index. This is our next position. I know these are edges, but let's just say this is our next position. These two things equal each other, right? So let's say x is equal to current position dot column, right? So we'll do x, or actually let's just do column. I don't want to mix x and y because it's confusing when you do that. Rows and columns versus x and y's, I think it's confusing. So there we go, we got column. Then we do our overlap checks. We have our minimum edge is the current and the next row, whatever the minimum, and then we get the max of those values as well. Then we get the overlap start, which will be the maximums of our minimums. They will be the maximums of our minimums. Then our overlap end will be the minimums of our maximums. Yeah, minimums of our maximums. Then we do overlap end is greater than overlap start. We've intersected, we return true. Then we come down here and we say, okay, well, if we're not on a vertical edge, then we have to be on a horizontal edge. And if we're on a horizontal edge, then we want to check if the current row is greater than the rec min row and the current in the current position row. Let's do what we did above. Let's set row equals current position dot row. Like that. Then we can rewrite this to be row. Oh fuck, did I think I flipped these checks, didn't I? Should be greater than the max, right? If it's greater than the min, it's greater than the max. That doesn't make any sense. That's never going to be true. Same thing here. This is never going to be true. Man, I've had a lot of bugs. Yeah. Woo! Sorry about your ears. Let's fucking go, man. Okay, I think this is the answer. I mean, we got the answer we expected for the input. I guess we'll try it. Let me get the drum roll. Let me get the drum roll sound effect. Alright, ready? Oh, hold on, I need to copy the thing it gave us. Moment of truth. Oh, shoot. Moment of truth. Alright, people, hold on to your hats. Oh, I wonder why Kelsey removed her comment. That was a funny comment. That was a funny comment. Kalashnikovs. Thank you for subscribing. Alright, here we go. Replay. Yay! Let's fucking go, bro. Woo. Oh. Ah. Dude. Oh my god, dude. That's a PR for me. That's a PR for admin of code. Let's go. I just completed movie theater, day 9, admin of code. PR'd. Let's go. Yeah, that was nastier than all get out. There's a term though for what this is. What is this called? There's a term for this thing. What do you... Thank you, Swap Indie. I appreciate it. Thank you, Stefan. Appreciate you guys sticking with me. A raycast. That's what it is. Yeah, so what do you... Yeah, what do you call... Or what is a raycast? No, not the app. Maybe I need to add like Polygon. There we go, raycasting. Raycasting is essentially the same as ray tracing, where visual lights are cast or traced on their path from the focal point of a camera through which each pixel in the camera sensor to determine which is visible along the way. Yeah, I think I had to do this last year. I just remember last year there was a problem where you had to like traverse a grid and you had to count how many times you crossed over the thing to figure out if you were still in the thing. Well, whoever came up with that is really fucking smart, because that's not intuitive at all to me. Yeah, okay. Well, I'm really excited about that, but that was really, really tiring. A laser that you shoot and check for hits. Yeah, that's essentially what I did. Yeah. Mochi Mochi, yo, do you like Rust? I just started learning Rust, and so far, you know, I'm like, Rust is like where Go is for me. Rust is not better than C# or TypeScript in my book, but it is a nice language. I'm barely though getting started with it. Like I'm writing Hello World programs with it, so take that for what it's worth, you know. Okay, this definitely needs to be refactored though, because this whole thing is really disgusting looking. So this needs to be refactored. But I'm just gonna leave that as a to-do, so we can so we can get started on day 10. So I'm gonna say to-do refactor below, so more understandable. And then we'll go to main test.go, and we'll put our answer here. I think the better game dev term is ray trace actually, but you could also say you're casting a ray. Ah, okay. That's why I think that problem, I bet if you were a game dev, that problem was probably like, oh, I've done this a half a dozen times before in my life. That was so far outside of my comfort zone in terms of problems that I've solved before. Like way, 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 way outside my comfort zone. Let's see if we can catch up and do maybe day 10's an easy day. Let's see. Basically, I need to go build some video games. Okay. We'll do git add. Is there really 117 people here? What is happening right now? Now I'm self-conscious all of a sudden. I did not realize that we had 117 folks now. Guys, do not think this is what good software engineering looks like. I'm just a guy in this basement in Kansas throwing shit against the wall to see if it sticks. Let's see, wit feature. Let's see, solve day 9 part 2. The dopamine feels good, guys. I won't lie. It feels it feels good. Okay, cool. GHPR, merge that in, and then we get started on the next day. And here we go again. So let's do git check out the Stephen Freeborn feature day 10 part 1. Set that up. Let's do new item, or not new item, make directory cmd 10. We'll do AOC. We'll download 10. 10. Day 10. And now we'll just start stubbing out our normal stuff. Also for day 10, ensure you've got your seatbelt. Oh shit. No! Dude. Let's see, main test.go. Yep. And then we also need our example. I need an easy day now, you know? I only got 30 minutes. I gotta, let's see, func solve part 1 file path string. We'll assume we want a number. Package main tests. We'll say func test solve part 1. T is a pointer to testing T. And we'll do if, or we'll do expected is something. We'll just set that equal to -1 for now. And we'll say result is going to be equal to solution. Not solve part 1. We'll say if result does not equal expected. And we can do error F, and we can say got %d, but wanted %d, result expected. And then we'll import the solution. Solution is a named import. Named import is this. Stephen Freeborn. Advent of code 2025 cmd /10. Go test. Hello, Anonymous. How are you doing? Good to see you. Ali, thanks for subscribing. I appreciate it. I am doing well today. We actually solved Advent for code day 10, which was day 9. Sorry, day 9 part 2, which was incredibly fucking difficult. Day 9 part 1 was like easy. This is easy, and then day 9 part 2 punched me in my face. But we've overcome that, and now apparently we're getting ready to walk into day 10, which is going to be harder. But other than that, yeah, we're having a good time. We're having a good time, Anonymous Panda, so glad to have you here. Okay, well, we can get rid of all this drawings. We don't need those anymore. And what we can do now is begin to look at day something. Alright, let's read day 10. So let's go back, return to your advent calendar, day 10. Alright, just across the hall, you find a large factory. Fortunately for the elves here, they have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline and none of the elves can figure out the initialization procedures. The elves do have the manual for the machines, but the section detailing the initialization procedure was eaten by Shiba Inu. All that remains of the manual are some indicator light diagrams, button wiring schematics, and voltage requirements for each machine. The manual describes one machine per line. Each line contains a single indicator light diagram, so our square brackets, okay, one or more button wiring schematics, which are in the parentheses, and voltage requirements, which are in the curly braces. So this is quite the parsing challenge. We should be able to use maybe some regex or something, but this is where, like, if you're doing good problem solving, right? First problem is, how do you parse this? Right? How do you parse the line? That's like problem number 1. Okay, so to start a machine, its indicators lights must match those shown in the diagram, where the period means off and the number sign means on. Good morning, Born to Shine. You are not late. You are right on time. Don't you know? A wizard is never late nor early. They arrive exactly when they mean to. Thank you for being a member too, man. I appreciate that a lot. It's very kind of you. The machine has the number of indicator lights shown, but its indicator lights are all initially off. So that's an important thing to remember. So even though the schematic for the indicator lights show on off, they all start off. So an indicator light diagram like period, hashtag, period means that the machine has 4 indicator lights which are initially off, and that the goal is to simultaneously configure the first light to be off and the second light to be on, the third to be on, the fourth to be off. So this is basically saying, okay, this is what your end state needs to be. You start with all off, and your end state is this. So this is your ideal end state. You can toggle the state of indicator lights by pushing any of the listed buttons. Each button lists which indicator lights it toggles, where 0 means the first light and 1 means the second light, and so on. When you push a button, each listed indicator light either turns on if it was off, or turns off. So it's basically we're basically dealing with like a Boolean, like a toggle switch. Press it, they go on. Press it, they go off. You have to push each button an integer number of times. There's no such thing as half presses, nor can you push a button a negative number of times. So a button wiring schematic like 034 means that each time you push that button, the first, fourth, and fifth indicator lights would all toggle between on and off. Oh, this is a little challenging, but essentially what we have is we have buttons that are essentially switches that control multiple switches. So our buttons basically control multiple switches. You press the button, 3 switches go up, 3 switches come down. 3 switches go up, 3 switches go down. Yeah. Okay. If the indicator lights were this, pushing the button would change them to this. Yeah, because so 0 is on, right? 0's on, and we push it, so now 0 goes off. But because 3 and 4 were off, they go on, right? So we're dealing with this like, we have to know what the current state is, and then whenever we push the button, we apply the toggle. Which is a kind of another interesting problem that you could think about, is you could basically think of a way to represent these structures and just have some method that you call right? So you could have a button that controls switches, and given a schematic, right, that button would know which of the switches it controls to flip them, right? So again, like breaking the problem down, we have the parsing problem. Now we have the state management of the button problem, or the switch problem, but we need to manage those switches through the button interface. Because none of the machines are running, the joltage requirements are irrelevant and can be safely ignored. Okay, this is a big red flag. Big red flag. Imagine I'm holding a big red flag. I'm guessing this is going to become important in part 2. Something about the joltage is going to matter in part 2. You can push each button as many times as you like. However, to save on the time, you will need to determine the fewest total presses required to correctly configure all indicator lights for all machines in your list. There are a few ways to correctly configure the first machine. You could press the first 3 buttons once each, a total of 3 button presses. You could press 1 3 once, 2 3 once, 0 1 twice, a total of 4 button presses. You can press all the buttons except 1 3 once each, a total of 5 button presses. However, the fewest button presses required is 2. Okay, so we're going to have some sort of loop, and we're going to need to keep track of the fewest presses each time we loop. Basically, one way to do this by... The second machine can be configured with as few as 3 button presses. The third machine has a total of 6 indicator lights that need to be configured correctly. The fewest presses required to correctly configure it, is 2. One way to do this is by pressing the buttons 0 3 4, 0 1 2 4 5 once each. Okay, so the fewest button presses required to correctly configure the indicator lights on all the machines is 2, 3, and 2. So you add all those together. What is the fewest button presses required to correctly configure the indicator lights on all of the machines? So that's basically a total of the fewest per machine. So the interesting part about this is the Boolean nature of these buttons. There's never really... You could press the first 3 buttons, the first 3 buttons once each. It's kind of interesting because really, Komodo, thank you for subscribing. I appreciate it. It's kind of interesting because the buttons are Boolean, pressing the button twice is basically equivalent to not pressing it at all. Yeah. Right? Like what I mean by that is if you press the button, so everything starts off, so everything's off. If you press the button, it turns the switches on. If you press the button a second time, it turns everything back off again. So it's like you never pressed it. The only time that matters is if like you turn it on and then you press another button and you come back to that button and you press it again. That's the only time where it really matters. Okay. So these are my inputs. So I think the first thing to do is we're not going to solve this before the end of the stream, but we can at least get the parsing and maybe maybe I can stream this evening and we can actually get this solved. So this is our example. Ryan, if you use a string split with a space as the delimiter, it should make parsing easier without regex. Yeah, I think that makes sense, right? I think I might still use regex though. But I like your idea about using space as the delimiter. Yeah, so I probably will use space as the delimiter, and then I'll just regex this stuff out, and then I'll do the same thing here. So the first thing we got to do obviously is we got to read the lines. So what's the right way? Let's just think about how we could represent this instead of just kind of what I did on day 2, part 9 was dumb. I just kind of tried to solve everything in one go, and I think that made it way more complicated and way more bug prone than it should have been. So let's try to break this down. So what are we dealing with here? We're dealing with the target state, right? We're dealing with the buttons. Or actually, I guess we could call these the switches. These are the switches that each button controls. And this is the joltage requirement, which we can pretty much ignore this for now, right? So let's not think too much about this. So let's say we have a type machine, which is a struct, and now our machine is going to have a list of switches, which is basically a map. And instead of using the characters, I think I'm just going to use booleans, right? Because they're using characters here, but these are basically booleans, right? This is false, true, true, false, 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 true, false, right? That's all this is. These are just boolean, on, off, on, off, on, off. So I think what we'll have is we'll have a machine that has switches, and the switches is a map of well, actually, it doesn't need to be a map. It just needs to be an array of bool, a slice of bools, right? And I can use the index because that's the way they set the problem up. So 0, this 0 right here maps to this guy over here. So if I get this button pressed, then I turn 0 on. So we can do switches, and then we can do buttons. I guess button. Yeah. Well, let's have a type. Let's have a type called button. And button has a list of switches it controls. Controlled. Maybe I'll do switches controlled, which is going to be a slice of ints. And then the machine is going to have buttons. And then I think what's going to end up happening, I think what I want to have is that each machine is basically knows how to get itself into the right state, right? So the logic for solving a machine is going to live in the machine, basically. You're going to have something like machine dot what is the end goal here? The fewest buttons presses required to correctly configure the indicator, right? So then I think what I'll have is I'll have something like that's like machine.configure, and then I pass in the what did they call it? They called it like a schematic or something. Each line contains a single indicator light diagram. So this would be like light diagram is what that is. Yeah, I think this is where we're going. And then we'll have something like machine.from line. So we're just doing some wishful programming right now, where we're just kind of trying to think about like how would we like this to work. I'm sorry, man, I can't read your username, but thank you very much for subscribing. That is not a you problem, that is a Steven that only speaks one language problem. Komodo Swag Dragon Part 2 of Day 10 has me mad stumped. GL, love the vibe. Oh, thanks, man, I appreciate that. Well, Part 2 Day 9 had me fucked up, man, so if that's the case, then Day 10 Part 2 might not be surmountable. Although now I'm kind of like, I'm happy because I've PR'd AOC. This is the furthest I've ever made it in an Advent of Code challenge within the 24 days. So everything after this is just icing on the cake, you know? My goal has been achieved. Ryan, you can do the same thing with each object with a comma to parse the different components of the string. Oh, that's a good idea too. Yeah, that's a really great idea, Ryan. I guess I just have to handle the parentheses, right? Yeah, because I could just do remove the lead or trim off these brackets and then split by empty. No, that's a good idea. So I'm gonna, at the end of the day though, what I'm gonna end up with is I'm gonna end up with a list of machines, I think. Or a list of button presses. Yeah, so this is gonna be buttons pressed. Like that. This is gonna be machine. And then this is going to be total plus equals buttons pressed. Which means then what we can do is we don't need to read all the files in, or all the lines of the file in. We can just say total equals 0. We can return total here. And we can do for line of file.read lines like this. And none of that exists. None of this exists yet. But I think at the end of it all, we can have something as pretty as this. And then we just need to solve each one of these problems. So we need to solve the parsing problem. And then we actually need to solve the heart of the issue, which is given a light diagram, how does a machine get its switches into the proper configuration? I'm not sure that this. I'm not sure if this is a good idea, what I've done here, but I'm going to leave it that way for now. So let's define a function that has a receiver of type machine, and it's going to have, oh, we can't do this. We got to do, this has got to be the new machine now. When we refactor this, we can move this to a separate file and have that nice looking API. We'll do line string this is going to return a machine. For now, this can just return an empty machine struct. And then now let's define a configure method. Or no, sorry. Func m machine. This has a configure. And this actually should be pointer to machine. This is going to return an int. And then this is going to take a slice of I'm going to say it takes a slice of Boolean, is what I'm going to say it takes. For now. And it just returns 0 for now. And then we actually are going to have to do kind of what Ryan was saying. We're going to split the different parts of the thing apart. So our diagram, our light diagram is important for two reasons. It's important for describing the state that we want the end machine in, but it's also important for telling us how many switches our machine has. So I will do parts of our line is going to be initially defined by strings.split, and we will split the line on space. And let me define light diagram really quick. Light diagram, just so that we can run the code without it being angry at us. Tyler Frame, you're getting so many more views than usual. Just don't forget us when you're famous. Ah, dude, I'm not gonna forget anybody. I don't know why there was a lot of people here this morning. For whatever reason, I looked up and there was like 100 folks here. How many are still here? There's still like 100 folks. So I don't know what's going on, but nice to see all of you. But good to see you, Tyler. It's good to see a familiar face. Let's see, Ryan. So look at the first character of the split string, which will determine what type of component it is. If it's print, add it to an array, then loop through the array and do the same thing with each nested array. I like it. I like it. Stefan. Hey, good to see you, Stefan. You came back. Or maybe you've been here the whole time. Congrats on 8K, by the way. Oh, did we pass it? Let's go. We passed it while we were on stream, huh? I try not to pay attention to that stuff. I still am suspicious that we're going to end up reverting back to 20 subs. It's a pleasant stream to watch. That's why people stick to it. Well, that's very nice of you, crew. It's very kind of you to say that. I don't know. I feel like quality of stuff is so subjective sometimes, you know, so all I know is it is my stream, right? It's my stream. I don't know if it's a good one or a pleasant one, but it's mine. Stefan, I was here the whole time. Yeah. Marquise, thanks for subbing, man. I appreciate that. Live coding is exciting, bro. Dude, live coding is actually, like, people, I don't think people understand why I bet, like, when my family sees me watching people program on YouTube, they're like, what the fuck are you doing? But yeah, it is enjoyable. It's fun to watch. I think the thing I like most about watching other people code or program is I just like to see how they approach solving problems, because sometimes I'll watch somebody and they'll do something and I'm like, wow, I would have never thought of that. I would have never taken that approach. And then I basically get better, because now when I do that, when I encounter stuff like that, now I have a whole nother like thought process I can use. It's like crowdsourcing improvement in a lot of ways, you know. Not that I do anything particularly interesting, but I like watching other people. Stefan just lurking. Well, Stefan, lurk away. We enjoy lurkers. I'm a lurker. When I hang out in Tim the Tapman stream, I just lurk. I don't really comment or chat much. Ryan, I just despise regex with a burning passion. Will do everything within my power to avoid using regex. I don't think you're the only one, Ryan. Whoever thought it was a good idea to hide a language inside another language. It's a very powerful tool, but yeah, it's frustrating. I always have to use, whenever I have to deal with regex, I always use this site. It's called Regex 101, I think. Yeah, this is the site I always use. I like it because I can stick my regex up top, and then I can just put in test strings, and I can see, like, does this actually do what I think it does? Because I don't remember all the regex syntax always. There's also some subtle differences too between certain regular expression engines, like C# regular expression engine differs, I think, a little bit in implementation in certain cases compared to other languages, which is kind of interesting. Oblivious, how else are you supposed to learn? You're right, exactly. No one's meant to reinvent everything from... No, they are not. And I think you're wasting time too, right, if you're doing that. Like, it's totally okay to stand on the shoulders of giants. I've never used the debug view. I've never used that before. Maybe I'll have to find an excuse to use it. I've only ever used this part. Where's the debug view? Maybe I have to put something in here. Yeah, see, this is what I like about it. I like that it does that. Or if you have a capture group in here, it will actually show you what you've captured. I like that a lot. Visual, I'm a big visual feedback guy. You know, I want to be able to tangibly see things. I think that's why I like debuggers a lot, is because I can visually step through and I can see the state of the program. Sorry, I have to respond to a quick message really quick. For whatever reason, Google kicked me out of my YouTube account. All right, back to parsing. So we have our parts, like Ryan mentioned. Steven, check Discord. Let me see. I'm checking it right now. Ooh, something from Mr. Fritz. I like Fritz a lot. I think his first name's Jeff. He's a YouTuber. What is this? Tab annotated markup language. Interesting. Is this new? Oh yeah, this is really new. The simplest hierarchical data format ever created. Just tabs and new lines. Interesting. Huh. I wonder why this exists. I wonder what use case this is trying to fill. You know how I feel tabs and new lines and spaces. I kind of prefer the semicolons and curly braces myself, but yeah, always happy to have something new to try. Look how good the syntax is. Everyone can understand it. I don't know. I feel like everyone can understand JSON just fine. Crew. Ooh, I need to wait for approval to get into Discord. I just approved you, Crew. Yeah, I put an application on my Discord server mainly just to keep the riffraff out. Like I've found that most people who like to kind of be scammy and trolly are kind of lazy, and so any amount of friction between them being able to scam you or troll you, and they'll just move on to somebody else. That's why my chat is subscriber only for 5 minutes, is because I kind of want to make sure that this stream and my Discord stays a place where people actually enjoy being, and not just full with a bunch of annoying, hateful, you know, mean. It's the dad in me, you know. It's the grumpy dad in me. This is a place for kind and generous folk. If you're an asshole, you can get the fuck out, you know. That's kind of how I feel. Alright, so we got our parts now. Now we need to actually, let's actually define what our parts are going to be. So the first part is going to be our diagram. Then we have our, oh, but these are separated by a space. Okay, so then we can basically say the first index is our light diagram part is parts 0, and then we're gonna say the buttons part is slicing parts from the first all the way to the final one, but not including it. So we'll say length of parts minus 1. Excuse me, I need to blow my nose real quick. Sorry, one sec. Crew, this is good. I will even check how they do it, because on my community Discord I have a problem with occasional spammers and scammers right now. I'm literally detecting that with my own bot, but this looks useful. Yeah, I just use Discord's approval thing, which, I mean, it doesn't keep everyone out, right? Like, there's still people who probably are willing to go through the effort of applying and subscribing for 5 minutes to troll. You know what I mean? Like, there definitely probably are people out there who will do that, but if it keeps out 90% of it, to me, that's a win. And then our joltage, which I guess we can ignore that, can't we? We can ignore the joltage for now. So let's just real quick, let's print these things so I can make sure I've done what I think I've done. So we'll do light diagram part. We'll do buttons part. I probably have enough time this morning to do the parsing logic, and then I have to get ready for work, unfortunately. Have to go to the real world. Yeah, there's our, yep, that'll work. And then we can split this. So we can say individual buttons equals buttons part. Well, this is an array. This is an array itself. Yeah. So we could do light diagram is going to be a slice of bool. And then we're going to loop over our we'll do light diagram part. This should be a rune. What is this? Yeah, a rune. And then what we're gonna do is we're basically just gonna deal with true and false values instead of dealing with hashtags and periods, because the hashtags and the periods, that's all they represent. They just represent true or false. So I'm gonna do if. We'll do if string C equals, let's see, equals string. We have to cast it since it's a rune. Or can we do C equals period? If C equals hashtag that. We could use a switch case. We could definitely use a switch case if we wanted to. We'll do light diagram at I is going to equal false. And then this will equal true. And then we'll also have a what will we have? Well, we have the length of the so we can do light or number of lights equals the length of the light diagram. And that's important because when we create our machine, we're going to want a couple things. We want the buttons, and we want the light diagram, or the number of lights, I think, when we create the machine. Again, I don't know if this is where this is all going to live, but this seems like a good place to start. So we have a number, and then this buttons part is basically a list of this, right? We have a list of these. And so what I'm going to do, and everyone's probably going to think different things, but what I'm going to do is I'm going to have a function that's called new button. And I'm going to allow the button to take care of parsing that individual text. The button should know how to create itself given that line, given the individual button lines. So we need to change this from a line. It also needs to accept a number. So it needs to accept the number of lights. And then it also needs to accept not a string, but the buttons as a slice of strings. And then what I'm going to do here is I'm going to say for B, we're going to range over the buttons that are passed in. And we're going to say, maybe I do buttons as strings or something like that. I know those are bad. That's a bad variable name, but it does describe what it is. And so we'll do, this will be our actual buttons, and we'll do a slice of button. And so each one of these is just going to be BS. So the B equals new button. We'll pass in the BS, and then we'll say buttons dot append. We'll pass in our B, and and then that will get set as the field on the machine. And then we'll do the same thing with our switches. So switches always start switches always all start false, right? So we could do for I range over number of lights, and then we could say switches equals Boolean slice, and we'll say switches at I equals false, and we'll set the switches. I think there's a more elegant way to initialize this, since we have the number, since we know the size of the slice and we know what the default value is. I think there's a more succinct way that we could initialize this, but I don't remember off the top of my head how to do it in Go. So I'm just gonna do it like that. And then the button is the one that has to worry about, this new button function has to worry about parsing this, which isn't terrible. What we basically need is we basically need to regex this. I know Ryan said don't regex it, but I'm gonna regex it. So we basically need a capture group where we capture going to capture one or more digits. That. Oh, and then we have to escape. We have to escape. Oh, no, we don't. We don't even have to escape. We can just do this, I think. So let's throw in our tests. Let's see if my regex works. Yeah, this should all work. Now these are strings, so we do have to parse them, right? So hold on, this isn't being caught. That's because this is optional. This is optional. So how do I indicate it's optional? No. There's some sort of optional way. Let's see. Regex, how to indicate. Vladimir, thanks for subbing, man. I appreciate that very much. How to indicate a character is optional in a match. Thought it was question mark. So you put it before. No, that's not working. Oh, actually, hold on. This can be even simpler. Yeah. I just want to capture the numbers, right? I don't really care. I think that works. Let's try this. And this can pretty much be arbitrarily big, and it's going to capture it as an individual group. Nice. So then we'll do, let's see, button regex equals regex.mustCompile, and we will do \d one or more times. That's going to be multiple matches, right? So let's return a button for now. Ryan, I'd still parse the joltage so you have it for part 2. Yes. I think we'll do that right here. We'll just put a note here that says no parse joltage here. I'm not going to worry about it until I need it. I'm not going to actually parse it until I need it. let's do format. Let's do matches equals button regex dot find all string. So we'll pass in our line, and we have to say -1 to get all the matches, I think. So format print line matches. Yeah. So run this again. We've broken something indexed out of range with length 0. What are we iterating over that has a length of 0? I always click away from the stack trace before I should. Main go 50, no, main go 64. Light diagram. Oh, yeah, because I don't want to do that. That's not what I want to do. I just want to append. So I want to say light diagram dot append false. Light diagram dot append. I could use that other syntax if I filled it first, I think. Why is this not working? What have I done wrong? Why? Por qué? Does anybody here watch the Primogen stream? Whenever he goes, Por qué? Por qué Maria? Or something like that. It makes me laugh every time. Let's see, we're on line 27 now. 27, 74. So who's actually throwing this? Phil Rue. Hello, Phil Rue. How are you doing? So new machine. New machine then iterates. Oh, I have the same issue here. So we'll do range over, and we'll say switches dot append false. Just fill in the array. Okay. And so now we have our matches, right? So let's go. Let's actually. I just want to make sure I'm getting the right matches. So we'll do format dot print line the line. Let's see, line. And this is matches. I tell you what, Chris James, the guy I learned Go from in Learn Go with Tests, he'd be very disappointed with me because I have not really done a test-driven approach to anything for Advent of Code, really, and he would be disappointed in me for that. See, line 1, 3, 2, 3, 2, 2, 4. Yep. That's all of them. But now we have to parse them, right? Because these are strings, and we don't want strings. We want actual numbers. So we'll say switches equals, or let's say switches controlled equals a slice of int, and then we will loop over each match in matches. And what will we do? We will. What will we do? We will say num is going to be equal to stir convert dot atoi. We will pass in our match, and then we will append that to to none, right? Then our button has its switches controls swept to that. Now again, I don't know if this is the right data structure. I don't know if this is the right representation. I might change this. But for the first pass of parsing, I think this will work. For now, it will work. And let's add to our machine real quick. No, actually to both of these. So to our buttons, we'll say type string, not stringer, sorry. We will do func button string. This will return format dot print or sprint f is b or percent what is it, s and then b, no, b dot switches control as well. Should this be percent b maybe? Yeah, maybe that's what it is. And then we'll add another to our machine and we'll say func m machine, and I'm going to make this string, and we will say, okay, how do we want to print our machine? I think we want to print our machine like this, where we say var stir the strings dot builder, and we will turn stir dot string like that, and we're gonna say string dot write string because I basically just want to be able to print a machine, and I want to see what its switches state are, and I want to see what the buttons it controls are. So, how do I want to do that? Well, I guess before I do that, let's just see what it prints by default. I'm curious what it prints by default. So, when we loop over the machine like that, see what it prints by default. Yo, check out in projects my post when you get time. It's fully open source, so I guess somebody will have use of it sometime. Yeah, let me look. Yeah, I'm always happy to check it out. You implemented Minecraft using C++? Dude, that's not just a small project. That's like a legit, you basically like rebuilt a game. That's pretty cool, man. That's far beyond my capabilities as a developer. That is very, very cool. I think I can here. Let me share it with hey crew, do you mind if I share it with chat? Do you mind if I post it here on YouTube in chat? But that's pretty cool. I don't mind. Yeah, I would love to, man. Here you go. Copy text. I know you guys can't post links, but I'd be happy to. Be new you. Thanks for subbing. Appreciate that. Bubs. Thanks for subbing, man. Appreciate you. Very kind. There you go. Minecraft C++. This is very cool. This is what crew just sent me that in our Discord server. He basically rebuilt a game. He rebuilt a whole game. Okay, so this is the machine. These are the buttons it controls. Yep, so everything should start off, and then we should have a list of buttons. Each button should have a list of buttons. I can make that. I can make that prettier though. You know, I can make that. I'm gonna make this prettier to print, and then I have to go. I need to go shower and get ready for work. So real quick, how do I make this prettier? Where is it? Did I delete it? I guess I deleted it. So we want type, where we want a function with the receiver type of machine. And this is going to be the string method so that we can print with it. And then we're going to return stir.string. This is going to be a strings builder like that. And then I think we'll have switch line. So we'll say stir switch equals sprint f, and we'll do %b. So we'll say switches this will be m dot switches like that, and then we'll do stir dot write string switch string, and we'll add a new line like this. And then for each of the buttons we'll say for, or actually what we'll do is we'll say stir dot write string, and this will be buttons like that. Put a new line there, and then we'll say for m dot buttons, we want to write to that string, so we want to say stir dot write string and just pass b in. Oh, range. Yeah, let's see what that looks like now when we print our machine. I'm just hoping this is a little bit easier to make sense of whenever I get into solving this. Okay, that did not work. Why did that not work? Is it because I'm not returning a... That did not work. There we go. So we have our switch. And maybe what I'll do is I'll write a header here that'll say something like stir dot write line or dot write string. I'm thinking like a C# dev. So this is just machine, and then this is going to be a new line. So at the very end we'll just say give me an empty new line. The string builder in Go is not as nice as the string builder in C#. I will say that. The string builder API in C# is very, very nice. Oh, and we need to put a new line under that. It is nice that they provide you with the string builder, you know? There we go. So this is our machine. This particular machine has switches and buttons. And each button controls these switches. Yeah, I think that's more that'll be more helpful to debug as I start screwing with the state of these switches. it will be helpful to be able, I think, to visually see that state along with the buttons. I'm actually going to not put this on a new line. Or actually, hold on. Yes, I am. I am going to do that. And then I'm just going to add a new line here so that the buttons themselves are also separated by a new line. Okay. Well, so that's the first part of the problem. The first part of the problem is obviously you got to be able to parse your machines. So we have our machine, we have our switches, we have our buttons. Now actually comes like the meat and potatoes of the problem, which is we actually have to implement this configure method to actually figure out what buttons to push, how basically the fewest number of pushes we can make to actually achieve whatever was passed in as the target. And that's what we're gonna have to do next time. Or actually, we'll try to do it this evening. I have to catch up. I'm basically a day behind at this point, so I need to stream probably one time in the evening to get back on track. So that's what I'm gonna try to do probably tonight. So if you're around tonight and you want to see me work through kind of the end of this problem, hopefully, please tune in. Obviously. All right, how many folks are still here? We have 150 folks here. There's no way there's 150 human beings right now here. That's fucking nuts. But unfortunately, I have to leave my YouTuber life and I have to go back to my real life, which is working a day job and having a family. So today is my last day of work, though. I'm off all next week. I don't know about you guys. Hopefully, you guys are taking some time off with Christmas and the holidays if you're here in the States. Bob Knoll, neglect your responsibilities. Code is life. If only. No, I've got a pretty good day ahead of me. It'll probably be a little bit of a short day at work. I got to go help at my kids' Christmas parties. Yeah, it'll be a good day. I've got some C# code to write at work. I've got some TypeScript code to write at work. It'll be a good day. So Ryan, like the stream, y'all. Yeah, it'd be super nice if you guys like the stream, but you don't have to. You can just hang out. Totally cool with that. All right, I'm gonna do my normal wrap up, okay? So if you guys are new here and you'd like to chat with me or anybody in chat outside of the stream, the best place to find us is our Discord. As far as my stream, if you enjoyed today's stream and you'd like to come back and hang out again, my normal schedule is 4:15 a.m. to 7 o'clock a.m. almost every day, and that's Central Standard Time. So I understand if you're in the United States, it's a little early and a little difficult to make it here. I totally get that. No pressure, obviously. And obviously, it's always kind if you see me live and you just stop in to say hi. That's always appreciated. You don't have to hang out the whole time. It's just nice to see some familiar faces like Stefan and Born to Shine and Ryan and Bob Knoll. It's really nice to see people that I've interacted with before in streams. As far as content for my streams, what you can kind of expect is for the next 5 days or 4 days, we're going to continue to try to finish out Advent of Code. And then we'll be moving on to some side projects. We'll kind of get back into the flow of less LeetCode-y style problems and actually trying to build some real life applications and websites and web apps. I'm primarily do web development stuff. All right, y'all. Other than that, I hope you guys have a great, Friday. I hope you have a great, wonderful Friday. If it's already Saturday for you, I hope you have a great, wonderful Saturday. And if I don't see you tomorrow morning, I hope I see you maybe in the comments of a short or a video in the future. Unbreakable Flow, thanks for subbing. I appreciate you. And I'll be back. So, yeah. Y'all rock. This is unbelievable if there's 100 people here at the end of stream. You too, Stefan. Have a good day, man. Stefan, you have a good day. Born to Shine, have a good day. Ryan, have a good day. Appreciate you guys being members. Stefan, Born to Shine, appreciate you guys being members. Bob Knoll, see ya. Crew, if you're still here, have a good day, man. Who else is here? Phil Rue, good to see you, Phil. I think that's it. Oblivious, if you're still here, have a good day, Oblivious. I think I covered everybody. All right. Bye, guys. Bye, chat. Bye. See you guys. Appreciate y'all. Have a great day, okay? Bye.